Good morning, everyone, and thank you, Olivier, for this introduction. So today, the topic of my talk is about quantifying the riverine sources of sediments and associated radiocaesium in the Pacific Ocean along the Fukushima Pref. So first of all, I would like to take the opportunity of these introductions to present myself briefly, as I started my research here since 3 months ago. So briefly, after a bachelor and master degree, which were related to the management of hydro systems and soils at the scale of gas systems and watersheds, I did a PhD from 2018 to 2021 at the Environment and Climate Sciences Laboratory under the supervision of Olivier. And during my PhD, I mainly conducted research on the use of fallout radionuclides following nuclear explosions. So mainly cesium-137 and plutonium isotopes to reconstruct soil redistribution rates, so to investigate soil erosion processes in South America. And so at the beginning of the year, I've been awarded a postdoctoral fellowship from the Japan Society for the Promotion of Science to conduct research here at the IRP with the help of my host researcher, Wakayama Sensei, and also other researchers from the institute, the MITATE Lab, of course, and Japanese organization. So, as you know, there have been, following the Fukushima Daiichi nuclear power plant accident, there have been large amounts of radionuclides which have been deposited, which have contaminated many catchments along the Fukushima prefecture. And in terrestrial ecosystems, cesium-137 was shown to be rapidly and almost irreversibly bound to the fine fractions of sediments. And therefore, the sediments will be transferred into the catchments and will lead to the contamination, of course, of the ecosystem. So, what is shown as well is that this transfer are mainly driven by extreme events here in the Fukushima prefecture. So this is a picture illustrating not the Fukushima prefecture, but a place close to the Tokyo area, following the Typhoon Hagibis in 2019, where we can see that there is a lot of sediments coming from the river, which can then be deposited into the sea. And of course, these sediments, which are associated as well with cesium-137 contaminants, will be is a matter of concern, especially for the Fukushima prefecture, considering that there is still fishing activity and so on. So, in addition, the cesium-137 contamination in transfer has been sorry. The transfer are mainly driven, by extreme events, as I mentioned before, so mainly cyclone. And as you can see, the temporal variability of the concentration, both in the particulates, so related to sediments and in the water, are still really important, especially in the Pacific Ocean. And one major issue is that we don't know the source of the sediments, where did they come from. So I will try to investigate during my doctoral research two main questions. So where does the sediment come from, and does it change with time? So to do that, I will briefly present some aspects of the methodology that I will use. So I will mainly use sediment fingerprinting approach. So this is a method by which the percentage contribution of different potential sources based upon land uses, soil type, or geology can be estimated. So providing crucial information, of course, of the sediments and associated contamination in the environment. And so these sources will be, of course, analyzed, but these sediments will accumulate in lakes or in the oceans into successive layers, which can then be dated to conduct retrospective analysis to analyze the temporal evolution of contamination in this marine environment. So I will mainly use results from 11 years acquisition of data, which have been made possible by MITATE Lab, by looking at, so I will investigate mainly the trying to apply this fingerprinting approach in 3 catchments, which have been highly contaminated, the Nisa catchment, the Hota River catchment, and the Ukido River catchment, where we have soils which have been analyzed over the last 11 years. And in addition, thanks to some organization here, so for example, the GAEA, sorry, the National Institute for Environmental Studies, and also the HIEHA, we have collected coastal sediment cores in the close proximity of the coast and to the north of the Fukushima Pref. And so this sediment core will be, of course, analyzed to determine the sediment's radioactive contaminations, Cesium-137, as well as some physical properties and geochemical properties. Of course, using the technique available here at the HIEHA, so gamma spectrometry for Cesium-137 measurements. We will also analyze the organic matter property to discriminate between different types of radiuses, the elemental geochemical concentrations for related to geology, here, the different catchments here, mineralogy, and also we will participate and work with other university here in Japan and probably the Koshi University to make some X-ray analysis of sediment cores and so on. So the idea will be, of course, to implement this fingerprinting approach in coastal sediment. And of course, as well, one part of my project related here will be to quantify sedimentation rates, so and changes in sediment source contributions in 2 dams located in the Fukushima prefecture, which have been extremely contaminated, so the Ogaki Dam and Yokogawa Dam, as well with the same techniques, but not apply this time on marine environment, but on Lake Twin environment. So thank you for your attention. I'm sorry I don't have a lot of results to share right now. And please let me know if you have any questions related to this. Okay.
Thank you, Pierre-Alexis. Are there questions for Pierre-Alexis in the room or online? Not, as we were a bit late, maybe you will help us recover.
Maybe not only your presentation, but also regarding to the what you have stated.
Sure.
During the sampling schedule, I think that there could be a decontamination process, especially on the field condition. And do you think that is there any effect of those decontamination process on the sediment or the profile of sediment?
It will be really interesting to see, especially in that marine sediment also in the dam. I think it is possible with, for example, the color of the sediment to investigate the effect of the decontamination. And I think there is a presentation this afternoon related to this topic, so I don't want to spoil. But yeah, it will be possible. Let's see if it's, I mean, all of this sediment fingerprinting have been mainly applied to Lake Twin environment and not really in marine sediment cores. So at the moment, I think it's a bit difficult to answer your question, but it will be something that should be investigated. Yeah. Mm-hmm.
Yeah, I guess this afternoon, Thomas has elements to typically discuss your question. So thank you.
We already think that origin of the sediment is coming from the manual forest. But in the case of the Fukushima prefecture, the contamination process can be one of the big sources for the sediment also. We would like to know that how the effect of the decontamination on the sediment. Yeah, I'm waiting for the afternoon.
Thank you.